Assalamu alaikum everyone. My name is Aisha Asif and I'm from Lahore. I'm working as a lecturer in Professors Academy. My graduation is from University of Lahore in Doctor of Optometry, and right now I'm doing my MS in Rehabilitation Sciences Low Vision. So today the topic of our discussion is enzymes. So let's move to our slides. So here we are on our slides. Today we are going to learn about enzymes. So in order to have a clear idea about enzymes, we have to learn about the catalyst in the first place. So what is a catalyst? A catalyst is a substance which can alter or speed up the chemical reaction without itself being chemically changed at the end of the reaction, which means that catalyst is something which speed up the chemical reaction, but at the end of the reaction have same mass as it is in the beginning of the reaction, which means it is not used up in the reaction. However, it just take parts in the chemical reaction. So the question comes to our mind here is how actually catalysts work. Basically, catalysts work by providing an alternative pathway for the reaction to occur. So this alternative pathway has a lower activation energy as compared to that having no catalyst. By activation energy, what we mean is it is the minimum amount of energy which is required to start up any chemical reaction. Here we have the diagram. We can also see it in the diagram. Here the red line shows energy provided with the catalyst, and this blue line shows energy which is provided without the catalyst. So here we see that the catalyst activation energy provided is being lower because there is more molecules with the required activation energy, and therefore more successful and more fruitful conclusion of the molecules will be occur as per second, and we have a faster chemical reaction. This is how basically the catalyst works. Next, we will talk about the enzymes. What are enzymes? Enzymes are biological catalysts which are mainly protein in nature. They alter the rate of the chemical reaction without themselves chemically changed at the end of the reaction. So which means that enzymes are basically substances, proteins, or in some cases they are ribonucleic acids, RNA. They speed up the biochemical reaction by modifying specific substances, which is known as substrate. Here you can see the diagram of substrate. This is the diagram of substrate, and this is enzyme. So enzymes are supremely selective in who they bind to, and they modify according to their specialty. Here the question arises in our mind is, how does a tiny small enzyme speed up the chemical reaction, biochemical reaction? Basically, enzymes perform a very crucial task by lowering the activation energy of any reaction. As an enzyme is a catalyst, it will lower the activation energy of the reaction. So the amount of energy, this is the amount of energy which is required to begin any of the reaction. The enzymes basically bind the substrate, hold them, and form any chemical reaction. This is also how the bond breaking and bond forming take place more easily. Actually, enzymes have a specific place in them, which is known as active site. This is the active site of the enzyme. You can see where the substrate bind to the enzyme. The active site is very specific. It has a very specific shape, very specific size, and a very specific biochemical behavior, and also a very specific arrangement of amino acids. Actually, the enzyme's active site, it is very unique only to a particular substrate. In addition, the active site has many enzymes consist of non-protein part, which is known as cofactors. Next, we will talk about lock and key model. This is the simplest model to represent how an enzyme actually work. The substrate simply fits into the active site to form a reaction intermediate, just like a key which fits into a specific lock. Here you can see in the diagram, the key is the substrate and the lock is the enzyme. So this substrate binds to the active site of the enzyme, and the shape does not change there. Rather, the structure of the substrate absolutely complements the structure of the enzyme like a puzzle pieces. Here you can see these are like puzzle pieces which fit. Here the substrate fits into the active site of the enzyme. Next, we have the model induced fit model. So this induced fit model shows that enzyme binds to the substrate, changes the shape. So the matching between the enzyme, this enzyme and the active site and the substrate is just not like a puzzle pieces fitting together. Rather than enzyme changes its shape and binds to the substrate even more tightly. Here you can see in the diagram. So this fine tuning of enzyme to fit into the substrate is known as induced fit model. So thanks for today.